Hello viewers, in this video lecture we are going to see one topic for the subject theory of computation, and the topic is languages of push-down automata from the third unit. Objectives are to understand the languages accepted by push-down automata and to analyze the problems to check for the acceptability for a language. First of all, see what is meant by the languages of PDA. Languages of PDA means languages acceptable by PDA. A language consists of set of strings that is produced by the given language format. So, a language can be accepted by push-down automata using two approaches. First one is acceptance by final state. Second one is acceptance by empty stack. Acceptance by final state is simply when we apply a string into the push-down automata machine, if after applying all the symbols of the string, if we are able to reach the final state, or if a string is able to produce the final state in our automata system, we can say the particular string is acceptable string. So that is the concept. So the PDA is said to be acceptable its input by the final state if it enters any final state in 0 or more number of moves after reading the entire input. So let P equal to push-down automata equal to Q comma sigma comma stack alphabet comma delta comma Q0 comma Z comma F. So we all know what it means. Q is the set of states. Sigma consists of set of input symbols. Stack alphabet consists of set of stack symbols. Del is the state transition function. Q0 is the starting state. Z is the starting stack symbol. F is the set of final states. So we can define the language accepted by the final state with the formal definition L of PDA, language of PDA equal to W. W means for string. W, when we use W to mention the string. So W, and having the state transitions like Q0 comma W comma Z tends to P comma epsilon comma Q. That means the system is moving from starting state Q0 by consuming the string W, and initially the stack will have the starting symbol Z, and finally the system going through the intermediate states like P, and finally the system reaches to the final state Q. So Q is one among the final state. So if it possible, if the system is able to produce the final state by consuming the particular string W, we can say the W is the string of language which can be acceptable by the PDA. And the second case is acceptance by empty stack. On reading the input string from the initial configuration for some PDA, the stack of PDA gets empty. That means when we apply a string to the PDA system, in some states some symbols will be pushed on to the stack, and sometimes the symbols will be popped up from the stack. That is based upon the logic of the problem. So finally, if the stack is empty, so in our logic, finally in most of the problems in phase 1, that is in the starting stage, we will push the symbols onto the stack. In the second phase, we will pop all the symbols from the stack. So finally, if the stack is empty, then we can see the particular input string is acceptable. So that is the case happening in the acceptance by empty stack. Finally, the stack should be empty. That is the condition. So here also we can say the formal definition for a given PDA. It is called as N of PDA. N of PDA equal to the same definition W, having the state transition function Q0 comma W comma Z tends to P comma epsilon comma Q. That is initially the system will be in Q0 and the string W will be applied onto the starting state. That means one by one symbols will be applied to the states, and the system will go through many intermediate states like P, and finally the system will reach the final state Q. Q is the final state. The state is not at all a matter. Q is one among the state. which is not mentioned. In this case, the Q is not mentioned as it is one of the final state. Q is one among the set of states, and the condition here is the stack should be empty. That is, the stack should reach, the stack should has only the Z, starting stack simple. Then we can say the given string is acceptable. Now we are going to see the equivalence of acceptance by final state and empty state. Here the case is if L equal to n of P1 for some PDA, that is L is the language for some PDA P1, then there is a PDA, second PDA P2 such that having the language L equal to L of P2. That means L of P2 is the language for the PDA P2, then N of P1 is the language for the first PDA P1. In two cases, the languages are considered for the acceptance of, one is for the final state, another one is for the empty stack. So in the first definition we can see it means the language accepted by the empty stack PDA will also be accepted by the final state of PDA. And another one same case is possible, that is if L is the language for L is the language, that is the L of P1 is the language for some PDA P1, then there is a PDA P2 such that L equal to N of P2. That is, L of P1 is the language accepted by the final state of first PDA, and the second case N of P2 means in this case the language accepted by the PDA by the empty stack. So both are equated, both are having the same acceptability. So that means the language accepted by final state of PDA is also acceptable by the empty stack PDA. Now we can see one example. Consider a PDA that accepts the language L over the set of input symbol 0, 1 by empty stack, which accept all the strings of zeros and ones, in which condition is a number of zeros are twice as number of ones. Number of zeros are twice as number of ones. So in our string we can have the input symbol zeros and 1, and the condition is if we are having based upon the number of ones and the number of zeros should be double in counter. So we can resolve the problem in two cases. First one is if 1 comes before any zeros. Second case is if 0 comes before any ones. So we can resolve for the first part, first case, that is 1 comes before zeros. So we can design the problem with two cases. The first case is if 1 comes before zeros. Here the logic is we read a single 1 and push 2 ones onto the stack, then we read 2 zeros, pop those 2 ones from the stack. The logic is when we read a single 1 we will push 2 ones onto the stack, then when we read a zeros, for each 0 1 will be popped off from the stack. So the corresponding delta functions will be del of q0, 1, z equal to q0, 1, 1, z. That is, when initially the system will be in the starting state q0, when 1 is applied as the input symbol, 2 ones will be pushed onto the stack, and then when 0 is applied, q0, 0, 1, 0 is applied, the 1 will be popped off from the stack. Nothing will be pushed, 1 will be popped off from the stack. So this will be written as del of q0, 0, 1 equal to q0, epsilon. No symbol is pushed on to the stack. So this will be represented as epsilon, and the system remains in the same state q0. And the second condition is, second case is if 0 comes before ones. Here the logic is that read first 0, when the system read first 0, push the 0 onto the stack and change the state from q0 to q1. That is, the state q1 indicates that first 0 is read and still second 0 has yet to read. And then from the state q1, if 1 is encountered, then we will pop 0 from the stack. So from the state q1 if one input symbol is consumed, zero symbol from the top of the stack will be popped. And again from the state Q1, if 0 is read, then simply it will read that second 0 and move ahead. Nothing will be happen. It will consume all the 0. Second 0, it will consume the second 0. And the corresponding delta functions will be del of Q0, 0, z equal to Q1, 0 z. Then del of Q1, 0, 0 equal to Q1, 0. Del of Q1, 0, z equal to Q0, epsilon. Nothing will be pushed. Then del of Q1, 1, 0 equal to Q1, epsilon. And finally, we can summarize all the state transition functions for the given PDA. So here the concept is, for a given language, we have to design the logic. Whatever things happening in the system, we have to design the logic. That is, for a given string, we have to assign what are all the operations have to be performed on the stack, what elements have to be pushed onto the stack, and what elements have to be popped off from the stack, and the condition is finally the stack should be empty. And finally, we have to summarize all the delta functions. So that's all about the topic. In this topic, we can have the questions like explain the concepts of push-down automata with example. Then we can have the questions like check a particular string whether it is accepted by the push-down automata, and sometimes we can have the questions like analyze the ways by which a particular language is accepted by the push-down automata. Thank you all.